Hi friends, welcome to Curie Electronics. This is the third part of Technician B Electronics 2017 VSSC question paper solution. If you have not seen the first two parts, you could see those. It will be useful for you. So we'll start with the first question. That is the 51. Up to 50 questions we have already solved. So this is the question number 51 and the third part of the question paper solution. Question number 51. We have to find the HCF of these three numbers. To find the HCF, you have to write the numbers like this: 12, 18, separated by comma, 24. Now we have to see which is the common number using which we can divide these numbers. So 2 without remainder. So 12 divided by 2 equal to 6. 18 divided by 9 equal to 2 equal to 9, and 24 divided by 2 equal to 12. So these all are multiples of 3. So we can divide by 3. 2 times, 3 times and 4 times. So HCF equal to highest common factor, which is equal to 2 multiplied by 3, which is equal to 6. So the answer is option C. Hi. Next question. The value of the expression. We have one expression. When you put x equal to minus 1, what is the answer? So x cube minus 2x square minus x plus 1. If x equal to minus 1, what is the value of this expression? That is the question. So minus 1 to the power cube minus 2 multiplied by minus 1 square minus of minus 1 plus 1. If I simplify this, cube root of minus 1 equal to minus 1. Square root of minus 1 equal to square. Cube of minus 1 equal to minus 1. Cube of minus 1 equal to 1. That is 2 multiplied by 1. This minus get multiplied, plus 1 plus 1. So this can be written as minus 1 minus 2 plus 1 plus 1, which equals what? Minus 1 minus 3, minus 3 plus 2, which equal to minus 1. So minus 1 is the answer. Question number 53. The op-amp can amplify. Op-amp can amplify. What is an op-amp? Op-amp, this is the op-amp. Simple. Op-amp will have a inverting terminal and non-inverting terminal. This is the non-inverting terminal. This is the inverting terminal. This is the output. Then it should be supplied. VCC minus VE. And an operational amplifier can amplify both AC and DC signals. So the answer is option C. Question number 54. You have to be extra careful when you get this kind of two table questions. It could go wrong. A and B are the inputs of a two input gate. Y is its output. Identify the gate whose truth table is given below. So for AND gate, what is the truth table for AND gate? AND gate, we'll see AND gate. If A and B are the inputs and Y is the output, A, B, Y. For AND gate, whenever the inputs are 1, 1, 0, whenever the inputs are, both inputs are high, we'll get output equal to high. So this is not a, this truth table doesn't represent and gate truth table. We'll try OR gate, OR gate. OR gate, if we take, we have A and B as input, Y as the output. So A, B and Y. 0, 0, 0, 1, 1, 0, 1, 1. These are going to be our input variable combinations. 1, 1, 1. See, OR gate, if we see, when it is 0, 0, output has to be 0. So it doesn't satisfy OR gate also. If we take, oh, this is sorry, it's OR gate, okay. If we take Y complement, then you will get, what you will get? You will get NOR gate. Complement of OR gate, you will get NOR gate. So what will be output? 1, 0, 0, 0. So this doesn't represent NOR gate also. So the answer is option D, none of the above. None of the above. So we'll go to the next question. Question number 55. What is the Q factor of a series circuit that resonates at 10 kHz, has equal reactance of 5 kilo ohms each and a resistor value 50 ohms? At resonance, what happens? At resonance, inductive reactance equal to capacitive reactance, which is in the question, it is given as 5 kilo ohm. Now Q factor equal to XL divided by or XC divided by R. What is the value of XL? XL equal to 5 kilo ohm, that is 5 multiplied by 10 to the power 3 or 1000. What is the value of R? 50 ohms. So which comes to 100. So the answer is option C. What is the resonance frequency? Equation for resonance frequency, FR equal to 1 divided by 2 pi root LC. The series resonance, series resonance, what happened to the current? If you draw, this is the current. At resonance, current reaches maximum. Current reaches maximum means this is the frequency, this is the resonance frequency. At resonance frequency, if it is a series resonance circuit, the current reaches maximum and the infinite and the resistance is minimum or impedance is minimum. Question number 56. Hello. Okay. When parallel resistors are of three different values, okay, we are just assuming resistors are connected in parallel means what? The voltage across them is same. Okay. Now, one resistor is 100 ohm, another is 10 ohm, and is 1 ohm. This is across we are having a 10-volt battery. Okay, 10-volt battery. Now maximum current will flow through which resistor according to Ohm's law? I equal to V by R. So the maximum current will flow through the 1 amp resistor, that is the lowest value resistor. Okay, so power equal to what? V into I. So the maximum power dissipation will happen in the 1 ohm resistor, that is the smallest resistance. Question number 57. Peak inverse voltage across a non-conducting diode in a bridge rectifier equals the peak value of the secondary voltage. I actually wanted to give you the table in this question, but I forgot. I'll make it up later. Okay. So what happens? Why? If it is a bridge rectifier, if it is a full wave rectifier, then 2 times the peak value will come. 2 times Vp will come across the diode or half wave rectifier also or half wave rectifier also. It will be 2 times the V peak, that is the secondary voltage. So here for a bridge wave rectifier, full wave bridge rectifier, this is one of the advantage. Okay. And what is the efficiency of full wave rectifier? That is 81.2. Okay, I'm not going in detail. We'll go to the next question. We'll go to the next question. Okay, question number 58. Which among the following is an incorrect characteristics of an ideal op amp? An ideal op amp should have infinite common mode rejection ratio and slew rate. So this is correct. Infinite voltage gain also should have an ideal op amp. Infinite bandwidth also expected. But the option D, infinite output offset voltage when input voltage is zero. This is not an ideal characteristic of op amp. So the answer is option D. And what is CMMR's common mode rejection ratio? It is given by differential mode divided by common mode. So if we have a op amp and this is our non-inverting terminal, this is our inverting terminal and this is our output. This is V1, this is V2. If for the differential mode, the input is going to be V1 minus V2. This will get amplified. It's a common mode means common mode in ACM. In common mode means V1 equal to V2. So it will be output should be nearly zero, and differential gain has to be high. Question number 59. How is your preparation? Of you are doing well. We are doing great, sir. Okay. Okay. Question number 59. For display of a sine wave in a CRO, what waveform is applied to the horizontal plates? See, the horizontal section of CRO is for time base. Okay. So always a sawtooth wave, that is like this wave, a sawtooth, a sawtooth wave is applied, that like this waveform. A sawtooth wave is applied to the CRO horizontal section, horizontal that is the horizontal plates. Then where the signal is applied? Signal is applied to Y plates, so that we can see the signal on the screen, CRO screen. Question number 60. Circuits that shift the DC level of a signal are called. The answer is clampers. This clamper is also known as DC storer circuit. See, if you have a waveform like this is a reference. This is a reference line. We can shift this waveform above the reference level or below the reference level If we shift above the reference level, it is a positive clamp. Below the reference level, it's a negative clamp. That is the negative side. And this circuit looks like this. There will be a diode. Then there has to be a load resistor RL. load resistor. And this is a diode is pointing away from the reference, that is the ground. So this is positive clamper. Okay, so we'll go to the question number 61. Question number 61. The output characteristics of common emitter configuration shows variation of VCE due to variation of IC keeping. So it is a question of how the output characteristics of a common emitter amplifier graphs looks. It is based on that. So this is going to be VCE, common emit VCE versus IC. So when you draw, we will get we will get output waveform like this. Here, this is maybe for let us assume that IB equal to 5 microamps. Here IB equal to 10 microamps. Here IB equal to 20 microamps. Okay. So see, if we see these characteristics of output characteristics, these output characteristics of C configuration. C configuration. See, we are keeping the IB constant and varying the VC and we are plotting the graph of VC versus IC. So IB is constant here. The output characteristics of common emitter configuration shows variation of VC due to variation of IC keeping IB constant. Now there's one more thing is there in the characteristic. One more concept is there with related this, that's a load line. This is a VCE. Load line is drawn for DC, okay, DC component. This is IC. Let us assume that this is our, we got one car. We can draw, this is a load line. At load line, this is equal to VCC by RC. Okay, this point is equal to VCC by RC. So this is the y-axis. X-axis, what is this? At this point, this is equal to VC. VC equal to VCC. Okay, and this is the somewhere here will be the Q point. Maybe this may be for IB equal to 10 microamps. This all will be useful for your exam. Question number 62. In a C configuration, an emitter resistor is used for. How do you make a C configuration? First of all, you have to bias before making a amplifier. So this is a common emitter. Base we will provide a voltage divider bias. So R1, R2, and the collector also we will have a load resistor. That's the RC. This will be connected to VCC. And to the emitter, one resistor is connected to ground. This is the R resistor. Okay, here we will apply the signals. So this resistor RE, this is used for stabilization. 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 So the answer is option A. Stabilization. Stabilization. Handwriting is very poor, very poor, guys. Question number 63. How many storage locations are available when a memory device has 12 address lines? 12 address lines, that means memory number of memory locations equals 2 to the power number of address lines. Address lines. Now what is the number of address lines? 2 to the power 12. What is 2 to the power 12? You should always remember 2 to the power 10 equal to 1024. This is known as 1 kilobyte. That is 1 kilobyte. Now if you when 2 to the power 11, you will just double it. You have to multiply by 2. It will be 2048. So 2 to the power 12 equal to 4096. So we have 4096. Answer is option D. Oh, lot of so many questions, so many zeros, so many ones. That's fine. Okay. Here we have to give this we have to convert the binary number to decimal, so we will use the power method, position power. So 11001 is the given number. When writing, be careful whether you are writing the same number or different number, because sometimes I will write different number and I will make mistake, so you don't do it. Okay, now this one is at the position of 2 to the power 0, is 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7. Now the zeros all will go off. It will all this we need not to calculate the zeros. So if this goes, this ones only we have to take fire. We have to sum it up, all these values, remaining values. That is 2 to the power 7 plus what is there? 2 to the power 6 plus 2 to the power 3 plus 2 to the power 0, which equal to 2 to the power 7. 2 to the power 5 equal to 32. This also you should remember quickly so that you can make it fast. So 2 to the power 7 equal to 128 plus 64 plus 8 plus 1. 120 plus 80, 120 plus 60, 180. 8 plus 4, 12. 192. 92 plus 9, 201. This is 201 to the base 10. So, done. Question number 65. The logic family with the lowest power dissipation is, that is what is the lowest power dissipation is? The CMOS. CMOS is the answer. CMOS. These are different logic families. CMOS. Lowest power dissipation. Lowest power dissipation. Then what was the, then what is other thing? Maximum fan out. Maximum fan out also there. Fan out means it can drive many other inputs, many other IC inputs. That is what the maximum fan out CMOS is having, maximum fan out. And density also, density maximum, density maximum. That means in a unit area, we can accommodate more gates using CMOS technology. Here one more is there, emitter couple logic. Emitter couple logic. This is the fastest, and it won't go to see this switching. This logic all works with the switching of transistors. This emitter coupled logic family doesn't go to saturation. The DOES doesn't goes to saturation. What will go to saturation? The transistors won't go to saturation. Okay, that is how it works faster. And one more point I'll tell you, the noise margin of TTL gate equal to zero point 0.4 volt. Noise margin. DTL means diode transistor logic. So guys, we'll go to next question. Question number 66. When 30 volt is applied to 4 series resistors, 60 microamps flows. If R1 equal to 42 kilo ohm, R2 equal to 47 kilo ohm, and R3 equal to 56 kilo ohm, what is the value of R4? What is the value of R4? See, whenever we, in a question, there's voltage, current, and resistors are there. First, you have to take care of the units. That is, voltage. Always keep it in volts. Current. Next is current. Always keep it in milliamps. Next is resistance. Always keep it in kilo ohms. Okay. Now, so what is resistors? All four resistors are connected. We'll just draw the diagram. One, two, three, four. Four resistors are connected in series, and a 30 volt is applied here. 30 volt. Current is given as 30 microamps. I equal to 30 microamps, but we want it in milliamps, which equal to what? If we divide by 1000, we will get it in milliamps. 0.06 milliamps we got. So first take care of the units, then you can easily solve it. So what is the R1 resistor value? R1 resistor equal to 42 kilo ohms. Don't worry about the unit. We have already taken care. This is 47 and 56. And the question is, what is the value of R4? R4 is the question we have to find. Now what is, we know I. I equal to C. In a series circuit, I is same. That is, I is what is flowing here? 0.06 milliamps. Now, RT. What is RT? Total resistance equal to V by I. What is the V here? 30. 30 divided by 0.06. It comes to what? 0.06. 30 divided by 0.06. We can multiply it by 100. That is 3000 divided by 6. 500. What is the value of the unit? Kilo ohms. And already we have decided how we are kept. 500 kilo ohm we got. 500 kilo ohm we got. Now it's easy. In a series circuit, RT equal to what? R1 plus R2 plus R3 plus R4. We know. So RT also we know. That is 500 equal to what is R1? 42 plus 56, 47 plus 56 plus R4. Now R4 equal to what? R4 equal to, what is R4? I'll write it on top. I'll go here. R4. R4 equal to what? R4 equal to 500 minus sum of these three. 42, 42, 47, 56, 40, 40, 80. 80 plus 50, 130, 137, 139 plus 6, 145. 500 minus 145, 355. What is the unit? Kilo ohms. And remember this, okay? Follow this method so you need not to worry about anything else. 355. 355 kilo ohms. Answer is option C. Question number 67. In a class B push-pull amplifier, the transistors are biased slightly above cutoff. For what? To avoid crossover distortion. I have not explained you this push-pull amplifier, complementary amplifier, those portions in any questions. I will put a small video for it. Question number 68. There are no transients in pure resistive circuit because why there is no transient? Transient is front of capacitors and inductor. If these two are not there, transient won't come there. Okay. For transient in any circuit, it required either one of these or both. So there are no transient in pure transistive circuits because they have no stored energy. These are energy storage elements. If there is no energy storage elements. Battery is a different case, okay? Don't consider battery in these transients. Question number 69. Which of the following transistor amplifier configuration is used as a buffer for impedance matching? So we'll for impedance matching we will use a circuit like this, which is wrong. So this is our output. Here I will take the output and here I will apply the input. So what is this? So what is this? This is a common collector. This is a common collector configuration. So common collector configuration is used as for impedance matching. For impedance matching. What is the voltage gain in common collector? Which is equal to gamma. It is gamma. It is less than 1. Less than unity. Less than 1. Common collector. Okay, in common emitter. Okay, I don't want to confuse it. Okay. It's a common collector configuration. In common emitter configuration, you see common emitter configuration. What is beta? Beta is the current gain, which is given by IC by IB. Okay. From here, one more relation comes. Alpha equals no beta. Beta equals to alpha divided by 1 minus alpha. This alpha comes from the common base configuration. Common base configuration. Okay, I hope all of you knows. In common base means what is the alpha for alpha equal to delta IC divided by delta IE. This is the alpha value for common IE. So these are the things you should know. But for this question, common collector configuration is used as a buffer for impedance matching. Question number 70. An instrumentation amplifier has a high output impedance. No, it should be low output impedance. Okay, not high. Power gain also for instrument amplification, power gain is low actually, not high. The answer is high common mode rejection ratio. Already I have explained to you what is common mode rejection ratio. Is the ratio of differential gain of the operational amplifier to the common mode gain of the operational amplifier. The common mode means both the inputs. See, common mode means both the inputs are we are giving same signal to both the inputs. This V1 and V2. V1 equal to V2. When it happens, noise comes like this. It will affect both the IC pins. This noise get induced in a similar value, so it get nullified. So an instrumentation amplifier should have high common mode rejection ratio. How all of you are sleeping? No. Question number 71. typical expected lifetime of LED light is? The answer is option C. It is LED lights can go from 20,000 to 50,000 it can go. Okay. If we divide by 10 these numbers, if we divide this by 10, we will get CFL lifetime. That is 2000 to 5000. Okay. So we'll go to the next question. Question number 72. The bandwidth of television channel is in India, the bandwidth is 6 megahertz. It's a direct question. One more thing, in TV, television broadcast, how the sound waves, what modulation for sound, what modulation is used for sound in TV? It is frequency modulation, FM. What is the range of normally? Okay, FM. In our FM band, what is the frequency range of FM radio? FM radio. What is the frequency range? All of us knows. 88 megahertz to 108 megahertz is the FM frequency range. Okay, and for video in TV, for video, what is TV video? What is used? That is VSB, vestigial sideband transmission. This is used for video. Question number 73. Question number 73. A conductor of 100-meter length with 1 mm diameter has 1 mm diameter has a resistance of 900 milliohm. What will be the resistance of another conductor of same material with the same length and 3 mm diameter? Okay, now given us, what is the given thing? We'll write it. What is resistance equal to? Rho, resistivity, N by area. Okay. What is the given resistance? That is 900. Okay, what we need to find out from the first. See, if we know the resistivity of first material, we can find the resistance of the second material. So what is the rho? We will write it. What is the rho? Rho equal to RA divided by L. Cross multiplying it. Okay. L will come down. A will go with the R, and rho equal to, this is what, rho L, which equal to, what is the value of R? 900 milliohms, 10 to the power minus 3 multiplied by, what is area? Area equal to pi d square by 4, pi d square by 4 in the numerator, all divided by length. Her length he has given us 100 meters. We will simplify this, which equal to, rho we are finding, rho equals, so 900 multiplied by 10 to the power minus 3, 3.14, 3.14 multiplied by d. What is the 1 mm diameter he told? It is in mm. So 1 into 1, it will be 1 mm square. When we convert it to meter, it is 1 multiplied by 10 to the power minus 6. Okay, this conversion you should know, otherwise you can't solve it. So check yourself. Divided by 4. The whole divided by 100. So this get cancels. If we solve this, it comes to, now we can solve it. See, 3, just take it as 3 nines are 27. 27 divided by 4, you will get around 7. Rho equal to 7 multiplied by 10 to the power minus 9 ohm meter. See, ohm meter, we have used meter for all, so we got an resistivity in ohm meter. Now we know the rho. Now for the second material, we have to find the resistance. That's I'll take it as R dash. R dash equal to, what's R dash equation? Rho L by A, which is equal to, what is rho? 7 multiplied by, what is rho? 7 multiplied by 10 to the power minus 9 multiplied by, what is the value of L? L equals 100 meters divided by pi d square by 4. Pi d square, what is the value of 3? 9 mm square you will get when you convert it into meters, 10 to the power minus 6 divided by 4, we will get it. Okay, now if we simplify this, so it becomes 7 7, okay, 9, okay, it's all right. Now if we simplify this, what happens? This minus 6 and this get cancels, and here will be 10 to the power minus 3, minus 3. It comes to, it comes to 10 into, so it comes to 10 to the power minus 6 3, then 100, 7 7, a row, 1 for second will be check, a row 10 to the power minus 6 L. See here I will divide by 4. 4, 9 divided by 4, what will get? 9 divided by 4. Okay, so when you simplify all these equations, not spending much time on it, you will get 100 milliohm. Please simplify it yourself. Okay, guys, sir, I can't do it. You have to do it, baby. Okay, question number. I think I will take click. Did I click? No. Answer is option B, 100 milliohms. 100 milliohms. See, it is very, this simplification also I'll tell you once more. It is very easy now. Pi into 3 nines are 27. 27 divided by 4. So we'll get 7 point something. So 7 7 cancels. So we will be left with 100 milliamps. Question number 74. In electromagnetic spectrum, visible light lies in between. First of all, whenever this electromagnetic spectrum comes, question comes, electromagnetic spectrum, you have to say I love you. I love you, baby. You have to say. That is, you have to write not I love you, baby. You have to remember this. Radio Mirchi. Radio Mirchi, everyone of us knows. Radio Mirchi, I love you. The rocks garden. You have to remember this. Now, what is the question? Where this is the light. You have to remember this sentence. You have to remember whenever a question comes from electromagnetic spectrum. So light left side. What is light? Left side of light? Infrared. Infrared is on the left. What is on the right? UV, ultraviolet. Ultraviolet is there. So the answer is option D. And one more thing you have to remember, visible light wavelength. Wavelength of visible light that equal to, it vary from 400 nanometer to 400 nanometer to 780. I think it is 780 nanometer. 400 nanometer to 780 nanometer. Question number 75. Question number 75. Two heaters rated 1000 watts, 250 volt each are connected in series across a 250 volt 50 hertz AC mains. What will be the total power drawn from the supply? Whenever what 1000 watts are or whatever value is there in the wattage, when 200 watts or 1000 watts are connected in series, effective power should reduce. So anyway, we'll find out. Now we will find out what is the value of each heater. R equal to what? What is the what? P equal to, okay, P is given. No? What is power? V square by R. Okay, which equal to what is V square? 250 multiplied by 250. We don't know R value, but we know power. Power equal to what? 1000 watts. 250 250 divided by R. Now R equal to what? R equal to 250 multiplied by 250 dt divided by 1000. 0 0 cancels, again 0 0 cancels. So what is the square of 25? What is the square of 25? 625. So divide by 10, 62.5 ohm. Okay. Now we got R equal to 62.5 ohm. Now what is the question? When these two heaters are connected in series, what is the power draw? So it is equivalent to two resistors are connected in series and applying 250 volt. 62.5, 62.5. Two resistors are connected in series. Okay, now we have to find the power. What is power? Power equal to V into I. What is the value of V? 250. Power equal to I, we don't know. Correct. I, we don't know. But power already we know. What is the equation for power? V square by R. What is V square? 250 multiplied by 250 divided by R. What is the value of total R? That R is, what is this green color R? Not green color R. Total resistance R. 125. 125. Divide what happens? 2 times. 2 multiplied by 250 equal to 500 watts. So the answer is option B, 500 watts. Question number 76. If E1 equal to A sin omega t and E2 equal to B sin omega t, then so we will just draw what he has given. Okay. This is E sin omega t. And one more waveform we have given, that is E2 equal to B sin omega. This we can take it as B sin omega t. E2 equal to B sin omega t minus theta. That's after some time. See, there is a lag is there comparing to the second wave of wave. E2 is lagging. After some time it starts. Okay, this is the E2. E2. This is E2. This is E1. E1. This is E2. This is the E1. Now what happens is a question. Actually here E2 E2 lacks E1. Where E2 leads E1 by theta. E2 doesn't lead. E2 is lagging. E1 is in phase, not in phase. In phase means they should come together. No, together. How together one girlfriend and boyfriend will walk? Same way together. It has to be. Then only it is in phase. A. E1 lags E2 by theta. E1 lags is telling. Actually, E1 is leading. So this is also wrong. So the answer is option D. None of the above. Question number 77. The RMS value of a sinusoidal AC current is numerically equal to its value at an angle of degrees. See, if we know Vp, it's a logical question. If you multiply Vp by 1 by root 2, what you will get? We will get Vrms. In case of cos, what is cos 45? 1 by root 2. What is sin 35? Sin 45 degree, which is equal to 1 by root 2. So, when the angle equal to 45 degree, we will get question number 78. In a simple high pass RC filter, if the value of the capacitor is doubled, the cutoff frequency is what happens. So RC filter is telling RC filter, high pass RC filter. How do you draw a high pass RC filter? A high pass RC filter is like this. There's a capacitor and there's a resistor to ground. This is the output, this is the input. This high pass RC filter, this is where high frequency will pass through, low frequency will go to the ground. Filter, what is the cutoff frequency of high pass filter? 1 by 2 pi RC. It is same for low pass filter also. Now this is for, now what is the question? In a simple high pass RC filter, if the value of capacitor is doubled, the cutoff frequency. Now I am going to this, I'll take it as FC dash, I am going to double it. What I get? 1 by 2 pi. Capacitor value is doubled 2C. Okay. Now if I can write what is FC dash, I'll write FC dash equal, that is the new cutoff frequency, equal to what? Wow, boy. Wow. Okay, now this 1 by 2 pi RC, the whole thing. See, if you see here, it is same as the above, that is 1 by 2 pi RC, correct? This is same as this. So I'll write it as FC. Now what is left? 1 by 2 is left here. That is this. This is left. 1 by 2. That is 1 by 2. It means the cutoff frequency has become half. So the answer is option A. Guys, one more. This VSSC gives some mathematics questions. So you have to be ready for it. Then only you can clear the exam with good marks. The hypotenuse of a right angled triangle is 6 centimeter more than the twice of the shortest side. The third side is 2 centimeter less than the hypotenuse. Find the side of a triangle. That means this side is shortest side x, and this is twice plus 6. This is 2x plus 6 minus 2. That is 2x plus 4. Okay. Now we have to simplify this using the Pythagoras theorem. Using the Pythagoras theorem, we have to simplify it. So, as per the Pythagoras theorem, hypotenuse square, that is 2x plus 6 whole square equals sum of the squares of other two sides, that is x square plus 2x plus 4 whole square. What is this? Is 4x square. All right. 2ab. 2x into 6x, 12x into 2, 24x plus 36 equal to x square plus 4x square plus 16x plus 16. Okay, so 4x square we can just move it and bring all numbers to one side, that is 24x plus 36 minus x square minus 16x minus 16 equal to 0. So 24x minus 16x is equal to 8x minus x square we got minus 16 equal to 36. 36 minus 16, that is 20. 20 equal to 0. Now first we will write minus x square plus 8x. This is 20, plus is there. Okay, plus 20 equals 0. Plus 20 equal to 0. Now we'll multiply this whole equation by minus, so that we can, our x term will be positive. Minus 8x minus 20 equal to 0. We have to find the value of x. I am not able to factorize it, so I will go with the quadratic equation. That is minus b plus or minus square root of b square minus 4ac divided by 2a. Okay, which equals, I'll write it here. What is the minus? It's minus 8. So minus of minus 8 plus or minus. What is the value of b square? B is 8. So b square equal to 64 minus 4 multiplied by a equal to 1. What is the value of c? Minus 20. Whole thing divided by 2 into a equal to 1, which equals to 8 plus or minus 64. It comes square root of 64 plus 80 divided by 2, which equals 8 plus or minus 144. 80 plus 64, 144. Square root of 144, which equals to 12 divided by 2, which equals what? We can write 8 plus 12 by 2. That is 20 by 2. 10 we will get. What is another value we will get? 8 minus 12 by 2. 8 by minus 4 by 2. We will get, no, 8 minus 12. If you write 8 minus 12, what will come? Minus 4 by 2. Minus 2 will get it. But actually we will take positive number only. So now we got x equal to 10. Then 2x plus 6 equal to what? That is 20 plus 6, 26. 2x plus 4 equal to what? 24. These are the, so the answer is option A, 10, 24, 26. So guys, this is the last question. All of you practice again and again. So we solve this question. So a car travels at an average of 40 km per hour in the first 2 hours. So first 2 hours, 40 km per hour. Kilometer per hour. The first 2 hours, and takes total 5 hours. Okay, so total 5 hours. Total 5 hours. This is 2 hours. This is 3 hours. Total 5 hours to cover distance of 230. What is the distance? Distance is total distance equal to 230 kilometer. 230 kilometer. What was the average speed in the last 3 hours? How do you find? The first 2 hours. What is the distance covered? 2 hours. That is 40 kilometer plus 40 kilometer. 2. 2 into 40. It comes to 80 kilometer he has covered in the first 2 hours. What is left? Now, in 3 hours, distance covered. Distance covered equal to what? Total distance, that is 230 minus 80. That is, if you subtract this, subtract 80 from 230, you will get what is the distance covered in 3 hours. That is 150 kilometers is covered in the last 3 hours. So 150, so 1 hour he will cover 50 kilometers. No need of mathematics, anything, we know it's a not daily day-to-day life question. So this answer is option C, 50 kilometer per hour. So friends, thanks for watching. If you have any doubt, please ask in the comment section, or if you want any particular topic questions, please ask in the comment section. So thanks for watching. I hope these videos are useful to all of you. So now we have completed 2017 question paper completely. So one more 2016 question paper, third part is pending. So the coming week I'll upload the third part of the 2016 question paper. Thanks for watching. See you.